Hey everyone, it's John here, and in this video we're going to take a look at 25 date and time functions in Excel. So there are actually only 25 date and time functions in Excel, so we're going to take a look at all of them. Now before we get started, make sure you hit the thumbs up button and subscribe to the channel for future Excel videos like this one. Now let's get started. Now before we get into all the date and time functions in Excel, I want to take a couple minutes to talk about what dates and times actually are. So dates and times are just numbers with either a date or a time formatting applied to them. So let's take a look at dates first. So these are numbers between 1 and 2,958,465. And if we apply some formatting to those to turn them into dates, let's go up to the Home tab and apply a short date format to those. You can see that those dates range from 1900, January 1st, all the way up to the year 9999, December 31st. So that's the full range of valid dates in Excel. And if we take a look at values outside of that range, so let's apply date formatting to these values as well. Then you can see what happens. So for 0, we get something that looks like a date, but there is no 0th of January 1900, so it's not a real date. And then negative numbers, or numbers that are too large, are displayed with pound signs. So dates and times that are negative or too large show as the pound signs. Now, similarly, times in Excel are represented as values between 0 and 1. So those are the decimal values of a number. And so here we've got a couple of numbers with some decimal values on them. Let's try turning those into times. So back up in the Home tab, let's go to format those as a time. And you can see that we get a value here. So 0.25, that's 1/4 of the day. And in other words, that would be 6 a.m. So 6 a.m. is 1/4 of the day. And as you would expect, 0.5, that's noon. And 0.75 would be 6 p.m. So the fractional value between 0 and 1 corresponds to a similar fraction of the day converted into a time. Now, the last thing I want to talk about is there are two very handy time and date keyboard shortcuts in Excel that are worth knowing. So the first one is Control semicolon, and that's just going to input the current date as a value into your cell. And then Control Shift semicolon is going to input the current time into your cell. So that's a brief review of dates and times in Excel. Now let's take a look at all the date and time functions in Excel. First up is the today function. So this is going to give us today's date. So whatever today's date is, that's what's going to be returned by the today function. Let's check it out. So the today function has no arguments. So we don't include anything in the parentheses of our function. Let's press enter and I get 2020 May 31st. So that's today's date for me. And if I came and opened up this workbook again tomorrow and pressed F9 to recalculate, then the today function would give me 2020 June 1st. So the today function is dynamic, and when it recalculates, it'll always display the current date. Next up is the now function, which is very similar to the today function, but it's going to give us the current date and time. So let's check it out. And again, there are no arguments in this function. And when we press enter, we get today's date and time. So today is May 31st, and it was 11:59 when I pressed enter. And again, the now function is dynamic, so when it recalculates, it's always going to display the current date and time. So if I press F9 now to refresh the calculation, you can see that it's updated to 12 o'clock. Next up is the year function. So this is going to allow us to extract the year part of a date. So let's check it out. So the year function has one argument. It just takes a date value. And let's press enter, and you can see that I get the year returned here. So from the date 2015, January 21st, I just get the 2015 value returned. Let's copy that down. You can see here we get 2020 from our 2020 date, and here's 2016 from our 2016 date. Next up is the month function. So this is going to allow us to extract the month value from a date. Let's check it out. And it takes one argument, takes a date value. Let's press enter, and you can see that we get the date value of 1. So from our date of 2015, January 21st, we get the value of 1, representing January. Let's copy that down. And you can see that here we have 12 for December, and here's 6 for June. Next up, the day function, which allows us, as you probably guessed, to extract the day from a date value. Again, just has one argument, and it takes a date. And it's going to give us the day part of that date. So here we have January 21st, and we get a value of 21. Here we're extracting the 31st, and here we get the 15th. Next up is the hour function. So this allows us to extract the hour value from a date time value. So it has one argument, and that's a date time value. And so you can see that our date time here was 6 p.m. and notice that this is formatted in the 24-hour format. So there's a value of 18 or 6 p.m. Now let's take a look at what happens when we have our date time formatted in the 12-hour format. You can actually see that what's returned, regardless of the formatting, is the 24-hour hour number. So here we have our date time formatted as 6 p.m., but the value we get is 18. So that's 6 p.m. in the 24-hour clock. Next up, we have the minute function to extract the minutes from a date time. And it takes one argument, date time value, and it'll just give us the number of minutes in the date time. So here we have a value of 6 because our time was 18:06. Here we have 15 and 9. Next up, and the last one of our functions that extracts a value from a date or a date time, is the second function. And it will extract the seconds value from a date time. So give it one argument, a date time value. And here our date time had 23 seconds in it, and we've extracted that value with the second function. Next, we have the eDate function. So this allows us to return a date a given number of months before or after a start date. So let's take a look at it. So this function takes two arguments. It takes a start date, and then it takes a number of months. So this is the number of months you want either before or after your start date. So let's take a look at -1 month. So that would give us a date 1 month before our start date. So here our start date was January 21st, 2015. And if we take that date and subtract 1 month from it. Then we'll get into 2014, December 21st. Let's take a look at the next example. So here we're starting on December 31st, 2020, and we want to add 2 months to that. That'll take us to 2021, and we'll be in February, but there is no February 31st, so we'll get to February 28th instead. Now, if we just add 0 months to a date, we'll get our same date back. And let's take a look at our last example here. So here we're taking our date and subtracting off 12 months. And so that'll bring us to the same month last year. So instead of 2020, we're in 2019 now. And February 2020 was actually a leap year. So here our date of February 29th doesn't exist in the previous year. So we end up on February 28th, 2019. Next up, we have the end of the month function, or EO month. Now this function is going to allow us to return the end date of a given month based on a start date and a number of months either before or after the start date. So let's take a look at this. So the end of month function takes 2 arguments. We need to give it a start date. In this example, let's choose January 21st, 2020. And the next argument is the number of months to offset that date by. So if we choose 0, we're going to remain at our current start date month. What we get is the end date in January. So January 31st is the last day of the month in January. Now let's take a look at what happens when we have a non-zero month number. So if we look ahead 1 month from January 21st, then we're going to be in February, and the end of the month in February is the 29th. So in 2020, we do have a leap year, and the end of the month function is going to take care of that for us. We can also use negative numbers for months. So let's copy this down and take a look at what we get with a -1 as our month number. So again, starting out in January 21st, 2020, and looking at the previous month, then we're going to be in December, and the end of the month of December is going to be the 31st of December, 2019. Next up, we have the date value function. So this function is going to allow us to take values that look like dates, but have actually been entered as text values, and convert them into proper Excel date values. So in this example, we have a couple values here that look like dates, but they've actually been entered as text, and we can tell that they are text because they're left aligned. So generally, text values are left aligned in Excel, and number values are right aligned. So let's use the date value function to convert these into proper Excel dates. So the date value function has 1 argument, and that's the text value that we want to convert into a proper date. Let's press enter, and you can see that we get a number here. So this is the serial number for our converted date value. Let's copy this down, and we can go up to the Home tab and apply a date format for this. And you can see that now we have a proper date based on our text value here. So we can see that we have June 15th, 2016, which is the text value date that we have right here. So the date value function was able to convert that into a proper date. Now, if we have a text value that's not actually a date, then the date value function is going to return a value error for that. Next up, we have the time value function. So this is pretty similar to the date value function. It's going to take something that looks like a time, but has actually been entered as a text value, and convert it into a proper Excel time value. So here again, we have some things that look like times, but are actually text values. And we can see that because they are left aligned again. Let's try using the time value function to convert those. So 1 argument, and that's just the text value we want to convert. And so here we get a number between 0 and 1, which is how Excel stores time values. And we can go up to the Home tab and convert those into a time format. Next up, we have the workday function. So this function allows us to return the next workday date from a given start date, either before that start date or after the start date. So let's take a look at how this works. So here I've got a list of dates set up. So these are dates in February. And then I've just highlighted all the weekends. And I've also highlighted a couple holidays in that range. And those are just made up holidays based on this list here. And the workday function is going to allow us to take into account those weekends and those defined holidays. So the workday function has 3 arguments. So we need to give it the initial start date. And then we need to give it the number of days away from that start date. And then the third argument is optional, and that's just a range of potential holidays that you want to ignore as work days. So let's select our list here. And the workday function is going to return February 13th. So here we're starting on February 6th, and we want to return a date that's 3 days away from that work day. And if we take a look at our little calendar, so here's February 6th, that's a Wednesday. And then 3 work days away, well, we would skip our Thursday, so our first work day is a Friday. Here's our second work day, and here's our third work day, and that's the 13th that the workday function returns. The workday function can also work backwards by supplying a negative number as the days argument. So let's take a look at that. So here we're starting on February 11th. So here's February 11th. It's a Monday, and it is a work day. And if we go back -2, we get to Friday, and then Wednesday is our next work day. And that's the 6th, and that's what our workday function is going to return here. Here we're starting on the 12th, and that happens to be one of our holidays. And if we go back to our next workday is Monday, and then Friday, so we should get the 8th. Next up, we have the workday.international function, or workday.intl. And this is similar to the workday function, but gives us an extra argument to specify what constitutes a weekend day. So let's check this out. So again, we need a start date, and then we need a number of days. And this time our third argument is what specifies a weekend. And so for this example, let's specify a weekend as being Thursday and Friday. So for this argument, that's a value of 6. And then again, we're going to specify any extra holidays as well. So here we're starting out on the 6th. So that's the Wednesday. And then we want to go ahead 3 work days. And now Thursdays and Fridays are holidays. So our first work day is Saturday, second is Sunday, and third is Monday. And that's the 11th, which is what we get here from our workday.international function. Similarly, we can go backwards if we specify a negative value. So here we're starting on the 11th. That's a Monday. And then -2 gives us a Saturday, or the 9th. That's what we get here. Here we're starting on the 12th, which is again a holiday, and -2 will get us to the 10th of February. Next up, we have the network days. So network days is fairly similar to the workday function, but this time we specify a start date and an end date, And then the net workdays function is going to calculate how many workdays are between those two dates. And again, we can also specify a list of extra holidays to exclude from that calculation. Let's take a look at it. So the first argument is our start date. And then the second argument is our end date. And the third optional argument is our list of extra holidays. Now here we're starting out on the 6th of February and our end date is the 13th. Let's take a look at that on our calendar. So here's the 6th. So that's a work day. So we have 1 work day, 2, 3, and up to the 13th, that's 4. So that's what we get for our network days. So you can see that network days calculates the number of working days between two dates, including those start and end dates as well. Now with network days, we can go backwards as well. So here our start date is the 11th, which is right here. And then our end date is the 6th. And so we have 1, 2, 3 work days in that range. And network days is going to return a -3 for that. Our last example here, let's start out on the 12th, which is a holiday. So we're not going to count that. And then we're going to go up to the 7th. So we have 1, 2 working days between that. And the 7th is actually a holiday. So we have -2 there for our network days. Next up, we have the networkdays.international function, or networkdays.intl, and this is the same as the network days function, but adds an extra argument to specify what constitutes a weekend. Let's take a quick look at this. So the networkdays.international function takes a start date and an end date. And then there's an extra argument for what the weekends are. So in this example, let's take a weekend as being a Monday or a Tuesday. So that's a value of 3. And then we can also specify any extra holidays with the last argument. So in this example, we're starting out on the 6th, which is a Wednesday, and that's a work day in our example. And then we're going all the way to the 13th. So we have 1 work day, 2, 3, 4, and 5 work days to land on the 13th. And that's what our networkdays.international function gives us. And we can also go backwards with this network days function. So let's start out on the 11th. That's a holiday here in our example, so we don't count that. And then if we go back to the 6th, we have 1, 2, 3, and 4 work days here. And so our network days function is going to return -4 in this case. Next up, we have the date function. So the date function just allows us to create an Excel date based on a given year, month, and day input. So let's take a look at this. So it has 3 arguments, 1 for the year, 1 for the month, and 1 for the day. So in this example, I'm giving the date function the year 2015 and the first month, which will be a January, and the 21st day. So I should get January 21st, 2015 as my date. And that's exactly what we get. Now let's take a look at a couple other examples here. Now if our day is bigger than our month allows, then that's going to roll over into the next month. So here I'm specifying January, and we have 33 as the number of days. So our date is going to end up as February 2nd. This works with negative numbers as well. So here we're in January 2020. And here I'm specifying -2 as the number of days. And you can see that that'll bring us into 2019. So the date function is going to return December 29th, 2019, because of that -2 here. Same thing happens with months. Let's take a look at that. So here we're specifying a 13th month, and that doesn't exist. So that's going to roll over into the year's value. So we end up with a date of 2021, January 5th. In this example, we specify a month number of -1, and so we end up in the year 2019 instead, and the date function is going to return November 5th, 2019, because of this -1 here. Next up, we have the time function. So this is similar to the date function, but allows us to create an Excel time value with a given number of hours, minutes, and seconds. So it has 3 arguments. We need to give it an hour value, a minute value, and a second value. And it's going to create that time for us. So here we've got 2 hours, 12 minutes, and 33 seconds. And we get a time of 2:12 a.m. with 33 seconds on it. Here we've specified an hour past 12, and because of that, we get a PM time. Now if we specify anything over 24 hours, so for example here we've got 25, then that's going to be equivalent to 1. So 24 is a full day, and then to get to 25 we have 1 extra hour, so we're back at 1 a.m. And this last example here, we have a number of minutes over 60, and that's just going to end up spilling over into our hours count. So here we specified 1 hour and 61 minutes. So that's really 2 hours and 1 minute. So we end up with a time of 2:01 a.m. Next up, we have the weekday function. So this function allows us to return a number based on what day of the week our date is. So let's take a look at this. So the weekday function takes a date as its first argument, and then the second optional argument tells the weekday function what numbers to return based on the weekday. Now, if we don't include this argument, by default, it's going to be a 1 for Sunday and a 7 for Saturday, and then 2 for Monday, 3 for Tuesday, etc. In this example, let's start our week on a Monday and go through Sunday. So the weekday function should return a 1 when our date is a Monday, a 2 when our date is a Tuesday, etc., all the way up to a 7 when our date is a Sunday. So we'll use a value of 2 for that argument. And let's copy our formula down. And here in our example, we have a couple dates listed. So we have the 6th, 7th, and 8th. And that's actually a Monday, Tuesday, and Wednesday. And so because we're starting our week on a Monday through Sunday, then the weekday function is going to give us a 1 for Monday, 2 for Tuesday, and 3 for Wednesday. Next up, we have the week num function. So this is going to give us a number based on what week we are in the year. Let's take a look at this. So this function takes a date as the first argument. And then we have a second optional argument, which is what day of the week to start our week counting on. And by default, this would be a Sunday. Let's start our week on a Monday. And if I copy that down, you'll see that January 1st, we're in week 1. And we're actually in week 1 all the way up until Sunday. And because we're starting our weeks on Monday, then the next Monday here is week number 2 onwards, all the way up until our next Monday, which is week 3, etc. Let's try starting our week on a Wednesday, which is actually January 1st. And here, if we copy this down, then we have a full 7 days that are in week number 1 in our example. And then starting from the next Wednesday, we're on week number 2. Next up, we have the ISO weekNum function. Now this function will return a week number based on the ISO week calendar. And this is essentially a leap week calendar. So some years are going to have a 53rd week in them. Let's take a look at this. So this function takes one argument, which is the date, and returns the week number. And let's just copy this down. And you can see that for the year 2020, we do actually have a 53rd week. Now, unless you're using the ISO week calendar, this is probably not a function that's worth exploring too much, but we just have it here for completeness. Next up, we have the YEARFRAC function. So this function will return a fraction of the year based on a start and end date. So let's take a look at this. So the YEARFRAC function takes a start date and an end date. And then there's a third optional argument, which is the basis for your fractional value of the year. Now we have various options for 30-day months or 360-day years. In this example, let's take the actual number of days in our year as the basis for our fractional value. And so in this example, we have a start date of January 1st and our end date is March 31st. So that's 1/4 of the year. And so we get a value that's just under 0.25. Here we've got a start date of June 15th and then an end date of July 15th. And that's about 1/12 or 0.08. And here we've got a start date of January 1st, 2019, and then our end date is March 31st, 2020. So that's a full year plus 3 months, and we get a value of about 1.25. Next up, we have the days function. So this is going to return the number of days between 2 given dates. Now, the first argument in the days function is actually the ending date. And then the next argument is the start date. And that's going to give us the number of days between those 2 dates. So for example, here we're starting on the 15th of June and then ending on the 15th of July. And there's 30 days between those 2 dates. Next up, we have the days 360 function, and this is very similar to the days function, but allows us to choose a different method for counting days in between our start and end date. This function, the first argument is actually the start date this time, and then the next argument is the end date. And then we have a choice of methods for calculating the number of days. So there's a US method and a European method. So here the start and end dates are approximated to a 30-day month. And here start and end dates that occur on the 31st of the month will be equal to the 30th day of that month. So for example, here our start date and our end date is on the 31st. So here we're starting on January 1st and ending on March 31st. And that's actually 90 days between those 2 dates. But our days 360 function only accounts for the 30th. So we get 89 days instead of 90 days. The last function we're going to take a look at is the DATEDIF function. So this function is going to allow us to determine the difference between a start date and an end date based on a couple different units of measurements. We can look at the difference in years, months, days, etc. Now let's take a look at this function. And one thing to note is this is kind of a hidden or unsupported function in Excel because of certain known issues with it. So you'll see that it's not listed in the IntelliSense menu. And when you do type out the function, the arguments aren't listed in the IntelliSense menu as well. So you just need to know how to use this function if you want to use it. So the first argument is the start date, and the second argument is the end date. And there's a third argument, which is the unit of measurement that you want to determine the difference as. So in this example, we're going to be taking the difference between these two dates as a number of years. And the DATEDIF function will return a 1. So here I've got January 1st, 2019 and January 1st, 2020. So that's 1 year apart. Let's copy this down. So here we're measuring this in months. And as you would expect, we get 12 months difference between those two dates and 365 days difference between those two dates. Now we have a couple other unit measurement types. So here we're looking at the difference between January 1st, 2019 and February 15th, 2020. And this unit of measurement here, MD, is going to return the difference, but ignore both the year values and month values. So our difference is based on the 15th to the 1st, which is 14 days. Now this is actually the unit measurement that has some known issues, so it's recommended not to use this. The next unit type here, YM, will take the difference but will ignore the year and the days and just return the difference as a number of months. So here we have a difference of 1 month. And the next unit type here, YD, is going to return the difference by ignoring just the years. So here our difference of 45 days is from January 1st to February 15th. We have a total of 45 days. So that's all 25 date and time functions in Excel. If you enjoyed this video, make sure you hit the thumbs up button and subscribe to the channel for future Excel videos like this one. That's it for this video. We'll see you in the next one.